Hello classes, this is Mr. Holmes. Today we're going to be talking about section 11-3, pyramids and cones. So I'm going to be going back with the pages I'm using from the packet and some notes not from the packet. I'm going to do most of the examples on a blank sheet of paper for more room. There's more space. But the first thing is we're going to derive the formula for the volume of a pyramid. So if we look at these two diagrams, it says how many pyramids could you fit inside the cube? Explain. So notice for each of these 3D figures, they have the same base, 2 by 2. So they have the same base area of 4. The height of the cube is double that of the pyramid. So if you look at this, how I could stack the pyramids inside the cube is I can place each of the pyramids as one of the sides of the cube. So I can put one on the bottom and the little point will be in the middle, like so. I can put one on the side, one on the top, one on the left, the back, the right, and so on. So I can fit 6 in there. I can place one on the bottom, the top, and all 4 sides around. So I can fit 6 pyramids inside the cube. So if I made the cube the same height as the pyramid, I'm basically just taking half of it. So if I take half of the 6 pyramids, I could fit 3 pyramids inside a cube with the same height, assuming they have the same base area shape. So this leads to our formula for volume of a pyramid. It takes 3 pyramids to fit inside a cube, so the volume of a pyramid is 1/3 the volume of a cube or a prism with the same height, the same base area. And this will be the same for cylinders and cones. And you could try it out. I'll show you a video with the filling it up with water with a pyramid and a cube with the same height, the same base area. It takes 3 of them to fill it up. But that's how you derive the formula. So I'm going to write out the formulas now for volume of a pyramid and volume of a cone. So volume of a cone. Well, let's start with pyramid actually. It's the exact same thing as volume of a prism, except the only difference is that it's 1/3 as much. It takes 3 of them to fill it up. So volume of a pyramid is 1/3 times the area of the base times the height of the pyramid. Pyramid. And this can just be abbreviated. Volume equals 1/3 times the area of the base, which is capital B, times the height. Volume of a cone is the exact same thing as a cylinder. Pi r squared h was the formula for volume of a cylinder, so the volume of a cone is just 1/3 times the area of the base, which is a circle, pi r squared, times the height. So that's the formula for volume of a cylinder or a cone. So for cone you need the radius and the height. Pyramid you need the area of the base and the height of the pyramid. And don't forget the 1/3. And remember, 1/3 just means divide by 3 or multiply by 1/3. So there's 2 ways to do the 1/3. You can put in the 1/3 or you can just divide by 3 at the very end. Both will give you the same answer. So if it was, I had to do 1/3 of, say, 30, I could do 1/3 times 30, which is 10, or 30 divided by 3, which is 10. So let's get into some examples now. So the first example I'm going to look at is this page right here. This right here. A rectangular pyramid has a base that is 3 times as long as it is wide. The volume of the pyramid is 75 and the height is 3. What is the perimeter of the base? So the first thing I do is write my formula. So volume equals 1/3 the area of the base times the height. In this case, I'm given the volume, I'm given the height. I'm not given the area of the base. So I have to figure out the area of the base, and once I know the area of the base, I then can use that to figure out what the dimensions are using the first sentence. The base 3 times as long as it is wide. So we're going to set up an equation. So the first thing I do is I substitute in volume is 75, the 1/3 I leave alone. I'll just do area of the base as capital B, and the height was 3. So I need to solve for area of the base. So 2 ways you can do it. You can get rid of each number first, but since it's all multiplication, what I like to do is combine all the numbers together. So in this case, 1/3 times 3, that's just 1. So I'm left with 75 equals 1b, and I solved. Works out where they cancel out, so I'm just left with b. If they didn't, then I divide by that remaining number. So the area of the base is 75. That's not the side of the base. So now basically I have a rectangle that looks like so. I know the area equals 75. It says the base is 3 times as long as it is wide. So if I let my width be x, then the length is 3 times as long. That's going to be 3x. And we know area of a rectangle is length times width. So if I multiply these together, length times width, 3x times x, that just gives me 3x squared. So the area, 3x squared, equals 75, because that is the actual area. Now I solve for x. So first thing I do is I divide by 3. I'm left with x squared equals 25. And that's just saying what number times itself is 25. That's a nice perfect square. So x equals 5 or -5, but we don't use negatives with dimensions, so it's just 5. So that is the side of my rectangle. So then the width is 5, the length is 3 times that, so that's going to be 15. So it's saying, what is the perimeter of the base? So then my sides are 5 and 15. So the perimeter, I just add up all 4 sides around. So 5, 5, 15, and 15. So the perimeter equals 40. So this was multi-step. I had to figure out the area of the base, use that to figure out what the side was, and then use that to get the perimeter. So multi-step. But it's the same process over and over. Next one, let's get into a cone question. A cone has a volume of 144 pi and a height of 12. What is the radius of the base? So sometimes they'll give you the volume in terms of pi. They don't actually multiply out the pi. They leave it in terms of pi. Sometimes you can take 144 and times it by the pi on your calculator, and it'll write it out. So it may say in terms of pi or written out the long way. If it's in terms of pi, you leave it with the pi in your answer. If not, you do it, multiply it out. So we have to figure out the radius of the base. So remember, for a cone, I go back here, it's 1/3 pi r squared h. So volume equals 1/3 pi r squared h. That's the formula for volume of a cone. In this case, I know the volume, I know the height, I have to find the radius, so I'm going to substitute in what I know. So volume is 144 pi. The 1/3 I leave, the pi I leave, the r I leave, and the height is 12. So now I have to solve for r. Since it's all multiplication on the right side, I'm going to combine these together, the numbers. So 1/3 times 12, remember 1/3 means divide by 3, so 12 divided by 3 is 4, so I'm left with 4 pi r squared. So it makes it a little easier to do now. Now I have to solve for r. So I have to get rid of the pieces not attached with the r. So I have to get rid of the 4 and the pi. I'm just going to divide everything by 4 pi. Get rid of it all at once. And if I divide 144 pi by 4 pi, The pi's cancel out, and then I'm just left with 144 divided by 4. You do that on your calculator, you'll get 36. So now it becomes 36 equals r squared. And to solve that, I just take the square root of each side. And that's a perfect square, 36. So it's just 6, your radius. If it said, what's the diameter? You just double it. The diameter would be 12. And that's how you go about working backwards, given the volume. If the radius of a cone is tripled, what is the new volume? What is the relationship between the volume of the two cones? So, we'll find the volume first, and then I'll show you a little trick to figure out the relationship without even having to do all the math. So if the radius of the cone is triple, so now the radius would be 18. We want to figure out the new volume. So volume is 1/3 pi r squared h. 1/3 pi, replace r with 18, and replace h with 12. So now I just do this all on my calculator, and we'll leave it in terms of pi, since this one was in terms of pi. So 18 squared is 324 times 12, 3888, and then times 1/3, which is dividing by 3. And you'll get 1296. So 1296 with the pi. That's the volume. So 1296 pi versus 144 pi. So what is the relationship? So if I divide 1296 by 144, you'll see that it's 9. It's 9 times as big. And there is a way to do this without having to do all these numbers. So I'm going to use my volume of the cone formula and show you what to do. So this is my volume of the cone, the pi r squared h. In this case, it's saying the radius is triple. So all I'm doing is looking at if this stays the same, each of these pieces, but the radius is tripled, what's happening? So I'm just looking at what's changing in my formula if I replace the radius with my new one. So when the radius is tripled, it's now 3r. It's 3 times as big, 3r. So what all I'm doing is now rewriting this in terms of my new radius, which is 3r. So 1/3 times pi times 3r squared times h. And I'm just going to expand this out. 1/3 times pi, 3r to the second power just means 3r times 3r, that's 9r squared, times h. So if I look at this formula now versus my original, the only thing different is this factor of 9. 1/3 pi r squared h will stay the same. It's just a 9. So that new number there tells you what is changing. So in this case, it's increasing by a factor of 5. Or sorry, increases by a factor of 9. So it increases by 9 times. So if you triple the radius, the volume increases by 9. If I quadruple the radius, it would be 4r. So then this would just be 16r. It'd be 16 times as big. So if something changes with the radius, you square that number, that's how many times it changes by. If the height changed, then it would just be by that factor. So if the height doubled, the volume would be doubled, since I'm not squaring anything. And you can always use this little trick to help you. So if you know what factor it increases by, then you could just, take your original answer and just times it by 9 instead of having to do everything in your formula. Okay, example 5. A cone-shaped hole is drilled in a prism. The height of the triangular base is 12. So that's saying this piece, the height of the base. Remember, the height of the base is different than the height of the prism. What is the volume of the remaining figure? So this deals with composite figures. I have to find the area of the shaded region. So basically, I'm taking the entire figure and I'm taking away this little cone piece from it. I don't need this. So this piece I'm taking out, removing. So with a triangular prism, it's on its base right now. It's not on its side. It's on its base. The base is a triangle. So remember, for a triangular prism, it's the area of the base times the height. So the volume of a triangular prism is the area of the base times the height. In this case, the area of the base is a triangle. The area of the base is 22 for the base of this triangle prism and 12 for the height. So for the area of the base, it's a triangle, so I do 1/2 times 22 times 12. Half of 22 is 11. 11 times 12 is 132. That's the area of the base. The height of the prism connects your two bases, so how tall is it? Since it's on its base, the height is just 8. So then the volume is 132 times 8. If we do that, 132 times 8, we get 1,056. I'm not going to worry too much about units till the end. It would be centimeters cubed if you do care about units for now. That's the volume of the entire figure. But I don't just want the figure. I want this cone taken out. So remember, volume of a cone is 1/3 the area of the base, which is a circle, pi r squared, times the height. The radius is 3. They give us the radius. The height goes from the top to the bottom, and we know that is 8. So the height is 8. The radius is 3. So I do 1/3 times pi times 3 squared times 8. And I'm going to multiply this all out. Remember, do the squared piece first, order of operations. 3 squared is 9 times 8 times pi. I'm going to write out that entire number times 1/3. And I get 75.39. I'm going to round that to 75.4. So that is the volume of the cone. So now, since I know the volume of the cone, all I have to do is subtract the two pieces to get the volume of the shaded part, what's left over. So the total volume is 1,056 minus 75.4. And if I do that on my calculator, I'm left with 980.6. Units would be centimeters cubed, because volume is cubic for whatever dimension you use. And that's how you go about finding the volume of a composite figure. Figure out what shape they are, subtract the big and the little. So the small from the big shape. Sometimes it could be a cone within a cylinder, it could be a pyramid within a cube, it could be a lot of different things. Okay, we're just going to look at a couple more here. So let's look at, we're going to look at 5, 6, 7. They're basic with the formulas. We're going to look at number 8, 9, and 10 with the, this is a hexagonal pyramid, a composite figure, box and a pyramid combined, and then this is a cylinder with a cone you're taking out. So I'm going to do this on a separate sheet for some room. Okay, so we're going to start with number 8. Number 8, this is a hexagonal pyramid. Number 8 I'm going to do right here. So with a hexagonal pyramid, the height is 5. And then the only other thing I need is the area of the base. They give me each side of the base is 2. That's all they give me. I need to find the area, okay? So we talked back in the past about how to find the area of the hexagon. You have to use the apothem, find the height of the hexagon. So I'm going to draw a picture, and we're going to use triangle relationships with that. So hexagon. Not the best hexagon. Don't make fun of my drawings, but that's what it looks like. So there's 2 ways I can go about it. So what I'm going to do is divide it into a triangle. There's 6 triangles around. If I start with the interior right here, a circle, it's 360 around. So if I do 360 divided by 6, I can get one of the interior pieces, which is 60. Or I can do the formula for to find the interior angle of a hexagon by using the formula n minus 2 times 180 divided by n to get one interior angle. If I did that, it's 6 minus 2 times 180 divided by 6. That will give me 120. So one of these angles right here is 120, and one of the inside angles is 60. So if I draw a triangle like this, I can now use this to figure out what from the center straight down the height. So I'm going to redraw this. Now another hexagon to show you what it looks like. So if I draw it straight down like this, if this angle was 60, then when I cut it straight down, it bisects it. So now this piece is 30. Remember, this entire angle is 120, so when I cut it, this is 60, and this is 90. So now I have a 30, 60, 90 triangle. I know this entire side from my picture before was 2. So if the entire side is 2, then this tiny piece is 1. So now I have a 30, 60, 90 triangle with the side opposite 30 as 1. So now I'm just going to redraw that. 30, 60, 90. So this piece is 1. And remember, with a 30, 60, 90 triangle, the side opposite to 30 is x, the side opposite to 60 is x root 3, and the side opposite to hypotenuse, the 90, is 2x. So if this is 1, this side is root 3, this side is 2. So now I know what the height of this tiny triangle is. So if I find the area of that triangle, I get 1/2 times 1 times root 3, which is just root 3 over 2. And you can put that as a decimal if you want. I'm going to leave it as root 3 over 2. So that's one of these triangles. So if I look at this figure, how many of these tiny triangles are there to make it up? So there's 6 triangles normally, but now I'm cutting it into 2. So there's 2, and since I have 6 of these parts, there's 12 total triangles. So if I take one of the triangles and I multiply it by 12, I get the entire area of the hexagon, which is 6 root 3. That's the area of the hexagon, which is the area of the base. So I now found the area of the base for the hexagon. That's my tricky part. Sometimes they give you the area, sometimes you have to find the area. So the area of the hexagon is 6 root 3. So to find the volume of the pyramid, I do 1/3 the area of the base times the height. And in this case, it's just 1/3 times 6 root 3 times the height of 5. And I'll do that on my calculator. So 6 times root 3 times 5 divided by 3 gives me 17.32, which rounds to 17.3. And my units were meters, so it's meters cubed. And that's how I go about finding the volume of a hexagonal pyramid, probably as tough as you'll see. But if you do it, that's your strategy. Make the hexagon into a 30, 60, 90 triangle. Figure out what the what we call the apothem from here to here. Then use that to get the area. And go from there. And it will always work. You're not going to see anything where it won't be a 30, 60, 90, or 45, 45, 90 triangle. Two more, and then we'll finish up. So we're going to look at number 9. So number 9, we have a box, and we have a pyramid on top. Though it looks like a cube, it's really not, because it's 12, 18, and 11, so it's not a square prism, it's a rectangular prism. Not all the sides are the same around. If it was 12 and 12, then we could say square prism, but it's 12, 18, and 11. So I need to find the volume of each, add them together. So number 9. What I'll do is this, so we can see it a little better. Okay. So, in this case, for number 9, we have we're going to start with the volume of the prism for the bottom. And that's just the area of the base times the height. The area of the base for this prism is just a rectangle, 12 times 18. And if I do that on my calculator, 12 times 18 gives me 216. And the height is 11. So the volume is 216 times 11. And 216 times 11 gives you 2376. And it's feet cubed. So we're halfway done. We found the volume of the bottom part. Now we have to do the volume of the pyramid. Remember, volume of a pyramid is 1/3 times the area of the base times the height. The good thing is we already know the area of the base. The area of the base is the same as the area of the prism. That is 216. The height, if this is 11 and the whole thing's 24, then the height from here to here is 24 minus 11, which gives us 13. So now I just substitute it into my formula. Volume equals 1/3 times the area of the base, 216, times 13. And just do that. 216 times 13, and then divide by 3. 936. So the total volume, I add the two pieces together, and this again was feet cubed. It's just 2376 plus 936. That gives me 3312. And that's the volume of the entire figure. And the last one we'll do is number 10. I'll just put this here and do it right on the side next to it. So 10, we have a cylinder and we're taking away a cone. So the first thing I'm going to do is figure out the volume of the entire figure and then subtract away the cone piece. So volume of a cylinder is pi r squared h. In this case, the radius of the cylinder is 8, the height is 9. So I just do pi times r squared, which is 8 squared, times 9. And we'll just do that on the calculator. 8 squared times 9 times pi, I'm going to write out the entire number, and I'll get 1809.557. And I'll just write that out for now. And it is, in this case, inches cubed. Now I have to figure out the volume of the cone, which is 1/3 pi r squared h. In this case, the height is still going to be 9. The radius, they give us the diameter now, the dotted line all the way across, so the radius is half of that, which is 2. So now I use my formula, 1/3 times pi times 2 squared times 9. So 2 squared is 4. 4 times 9 is 36 times pi divided by 3. And I'll get 37.699 for the cone. So the entire volume, I just subtract the two pieces, 1809.557 minus 37.699. So put that in, 1809.557 minus 37.699. That gives me 1771.858. And then it's up to you how you want to round it. It doesn't say on here, round to the nearest tenth, so this is going to be 1771.9. And we are finished. So that concludes how to solve questions with pyramids and cones. So from this video, I'll state the objective since I didn't do that at the beginning. You will understand how the volume formulas for pyramids and cones apply to oblique pyramids and cones. So if the figure wasn't directly on it, you just need the height. So it could be slanted, it doesn't matter, you still find the height like normal. And then you saw how to do 3D questions with pyramids and cones. Okay, again, remember it takes three pyramids to fill up a prism with the same height and same base shape area, and three cones to fill up a cylinder with the same base area and height. So this is Mr. Holmes signing off. Have a great rest of the day. Take care. Bye-bye.